Hello, Honors Pre-Calculus students. This is Mr. Cruzado, and we just went through a lesson on angular velocity and linear speed. Here are 3 practice problems. You can pause the video, try the problems, and then check to make sure you did it correctly. I will also be explaining them. So in problem number 1, we have a car that has a 12-inch diameter wheel. I'm going to highlight that. And you are traveling at 30 miles per hour. And we want to know the angular velocity in radians per second. So for this particular problem, we have 30 miles per hour, and the ultimate goal is to get radians per second. So I need to convert the hours to seconds. So we know 1 hour is 60 minutes. We know 1 minute is 60 seconds. So both of those numbers in green are 1. The next thing we need to do is convert miles to inches. So because the wheel is in inches, so we know that 1 mile is 5,280 feet. Again, we want the miles in the denominator, so the units will reduce. We know that 1 foot is 12 inches. And then the last conversion is we need to convert inches to radians. And as we discussed, the circumference, I'm going to write this at the top, the circumference is equal to 2 pi radians. So if you go around a circle, that's equivalent to going 2 pi radians. So the circumference of this particular wheel is 12 inches, 12 pi inches. That is the circumference, and that is equivalent to 2 pi radians. So now, if we were to pull out our calculator and multiply across, you will end up getting, and remember, we want to put a parenthesis around the numerator and a parenthesis around the denominator. And when you type this in, you get 88 radians per second. For problem number 2, again, we have a wheel. The diameter is 29 inches. Now, sometimes we will give you the radius, so make sure you read carefully. You are traveling at 45 miles per hour, and we want to know how many revolutions per second the tire is rotating. So I'm going to start with my rate, 45 miles per hour, and I want per second. So again, I'm going to use the conversion factors that 1 hour is 60 minutes, 1 minute is 60 seconds. Again, we need to convert miles to inches. So 1 mile is 5,280 feet. 1 foot, again, we want that in the denominator, is 12 inches. So another key conversion factor is 1 revolution is equivalent to 2 pi radians. Also, we know that 1 revolution is equivalent to the circumference. So the last conversion factor, we need to remove inches and get it to revolutions. So we could use circumference is equivalent to 1 revolution. So the circumference is 29 pi inches, and that is equivalent to 1 revolution. When you type this in your calculator, again, putting parentheses, you get approximately 8.69 revolutions per minute. Let's take a look at problem number 3. So in problem number 3, we have a wheel with a radius of 13.5 centimeters. It is rotating at 1,025 revolutions per minute, and we want to know the linear speed in meters per second. So I'm going to start out with my rate, 1,025 revolutions per minute. Since I want it in seconds, I'm going to convert the minutes to seconds. So we know 1 minute is equivalent to 60 seconds. And now I need to remove the revolutions. So we know, and I'm going to highlight this right above it, we know that 1 revolution is equivalent to the circumference that I'm highlighting here in yellow. So in the denominator, I could put 1 revolution, and the circumference is 2 pi r, so 2 pi times 13.5 centimeters. So that number in red is circumference is equivalent to 1 revolution. And then we need to convert centimeters to meters. Well, 100 centimeters is equivalent to 1 meter. And then if we use our calculator and put parentheses again, and we were to multiply across, we will get 14.49 meters per second. And just for emphasis, I'm going to show you that the units reduce out. So revolutions reduce, the minutes reduce, the centimeters reduce. So we're left with only meters over seconds. So I hope you found this helpful to talk about angular velocity and linear speed.